So for part two, one of the initial sources of error that I've been thinking about is the fact that we are estimating the initial conditions. And after going through the code many times, the initial conditions that I presented earlier, the ones that I came up with, and this is how I got my results. And on the right, you can see my code, and it just shows my processes where I change the lines to come up with things like the force of the black hole on the planet, the net force on the planet, and so on. And I repeat the same thing for the ship. And then at the bottom, you can see just like the velocity and position formulas, the update formulas. And then below that, it goes into the iteration that we didn't have to change at all. So let's move on to the discussion. What does it mean? If we look back to part one, the question is basically what's the difference between net force and the rate of change of momentum when you use one or the other. So if you're straight up calculating the net force for the object, you must use mass times the change in velocity over time, or acceleration. But by using the momentum principle, you can calculate dp over dt by using different variables, not mass, which is ultimately is equal to the net force, but it's not technically the same because you calculate it differently. And then moving on to what if, from part two, we're supposed to find initial conditions, initial velocities, which can help us orbit around the black hole. And I was not able to attain an actual velocity, but in order to calculate it, you would determine the velocity where the momentum is perpendicular to the net force of the ship, because that accounts for the orbit around the black hole. Thank you for listening to my lab. I appreciate it.